Good morning, everyone. In the last session, we started about the add method, add all method under this particular hash set. So we discussed hash set internally. It is working with a hash map. So we are placing a key as a whatever the object we are passing as a parameter, and the value every time we are trying to pass as a same object. So yesterday we discussed object at the 705. So this is an object we are passing as a value for each and every object here. So what we need to understand, so this particular key, it is going to play as an important role here. Okay. So whenever I'm trying to print this particular hash set, what is exactly doing? It is adding the data into the hash map. And whenever we are trying to print this, so just it is loading the only keys. It is not loading the values here. But here you can see whatever the order we inserted the value, we are not getting the same order. So why we are not getting the same order? Because internally we are trying to work with the hash code. So based on the hash code, the objects are going to be stored here. Okay, so this is what we need to understand. So we understand the add method and we understand the add all method, and at the same time, okay, so size method. So what exactly the size method is doing now? So let's say here I'm trying to write a size method. So it's a simple method, just it will try to return the how many objects are inserted as of now into this particular hash set here. Getting the point? How many objects are inserted? So that will return by the this particular size method. So now here you can see, now we are under the which class here? Hash set here. Okay. So now let me close all the classes here. I'm trying to open this particular size one more time. Now you can see we are under the hash set. So what is returning? Map.size. So what is the map we observe? So map is a reference variable of this particular hash map object here. Okay. So now if you go to this size method, simply it is trying to return the int variable. Now here you can see, so int we declare this particular size here. Now we are trying to work with this particular adding the values into this particular size here. Okay, so it's a simple understanding. We already identified in the earlier example also. So size will return how many objects are inserted into this particular current hash set here. And at the same time, so hash set dot is empty. So what we can do is empty method, basically it will try to return a boolean value. So if it is does not contain any value under the hash set, it will return true. Whenever the hash set will contain some value, it will try to return as a false here. It will try to return as a false here. So this is what we need to understand here. Okay, so now I will print the size, because the size will return the integer, and at the same time is empty also I'm trying to print, so that we can easily understand. So what exactly the is empty method will do now. Okay, here you can see size we are having 6. So you can count this 3 and 3, 6. Okay, so 6 record we inserted. So it is trying to return as a 6. So the boolean, whatever the is empty method we are calling, it is trying to return the boolean value. In our case, it is trying to get as a false. So why we are getting the false here? Because whenever the objects are not inserted into this particular hash set, then it will try to return as a true. Whenever we are trying to insert the value, so then it will try to return as a false. So it's a simple understanding, a map dot is empty if the size equals to 0. If the size equals to 0, then it will try to return as a true. But size, how many objects we inserted? 6. Now you can compare 6 equals to 0. Basically 0 equals to 0, it will return true. Okay, so this is only the one case it will try to return as a true, but any other cases simply it will try to return as a false here. So in our case we inserted 6 record, so it is not matching with 0. If you remember the double equals to operator, so what exactly it is doing? So now this is what we need to understand here. Getting the point? This is what we need to understand. 6 double equal 0, it is not going to be satisfied. In our case, it is trying to return as a false. Okay, so this is what we need to understand. The is empty. Is empty is a simple understanding whether the hash set is an empty or hash set contain any elements. So that is we can check here. So mostly we'll check the Boolean condition. If it is true, we'll allow the enter the values. If it is false, we'll do the some other operation. So this is the way we can check this is empty. Now what about this particular contains? Contains also we already discussed it. What exactly the contains method will do? Whatever the object we are passing as a parameter, the object is existed into this hash set or not, it is going to be written. It is going to return here. So in our case, we need to understand whether it is having any object or not. So now what we will do here, I'm trying to write the 458 here. Okay, 458. So we need to understand the implementation of contains, because each implementation class having different implementation for this particular contains, but the purpose is same. The purpose is same. Just whatever the parameter we are passing, the parameter value is existed into this particular hash set or not. Okay, if it is exist, it will try to return true. Otherwise, it will try to return as a false here. So now we need to understand the contains implementation. Contains implementation. So this is a contains method. Now I'm calling map.contains key. So carefully observe. Internally, what is the method we are calling? Map.contains key. So just we are checking the key. We are not checking any value here, because the hash map we already discussed. It is going to be stored as a key value pair. It is going to be stored as a key value pair here. Okay. So this is what we need to understand. Whereas a hash set, it is going to store as an object. So that is, we'll call it as an element. Okay, this is the difference we need to understand here. Now contains key. So here what we are doing here, now if you observe carefully, we are generating the hash code. Getting the point? Here we are generating the hash code. After generating the hash code, we are trying to find out the node. If any node is available, then it will try to return as a true. Otherwise, it will return the false. Okay, first we'll see the hash code. So this is the hash code we are trying to generate here. Now we'll go to the get node method. Now you can see hash code we are having 51671. Okay, 51671, and this is the key. So what we are doing here, so here whatever the condition we are checking here, so table not equals to null and table length also greater than 0 first. Okay, the table, it should contain some value, then only we can compare the given object here. So in our case, we are having some records here. Okay. Okay. So here, what we are doing is, so this is the condition is satisfied. This is the condition is satisfied. But here, what we are using? We are using the AND operator. Here we are using the AND operator. So whenever we are using the AND operator, what we are doing? So based on the hash, so we are loading the object from this particular table. The record we are initializing into this particular first. So now you can see the first, it is not initialized any record. Why it is initialized? Why it is not initialized here? Whatever the hash code we provided. Okay, whatever the hash code we provided. So based on the hash code, we don't have any record under this particular table. Correct? So we don't have any record because the 458, as of now, we did not inserted any record. As of now, we did not inserted any record. So simply it is trying to return null. Here we are having the entire this particular method. If it is returning not equals to null value, then it will try to return true. Otherwise, it will try to return as a false here. So now we are coming out of this. Okay, we are coming out of this particular method. So now you can see simply I will call the contains method within the println method so that we can print this particular value. So now I commented size and is empty. Now we'll see the contains here. Now we'll see the contains. So what is the value we are going to get? Basically false. We are getting the false value. Okay, so this is what we need to understand here. So why we are getting the false? Because the 458, now you can see it is not available here. It is not available here. So we have a value that is called 456 here. Okay, we are having the value 456 here. Now again I'm trying to run the same example. So now carefully observe. So contains key, hash code. Okay. After the hash code, we are going for the node. Now what you need to understand here, so you need to understand the table not equals to null, and this condition is also now satisfied here. Getting the point? Earlier what we did basically, whenever we are checking this particular condition, what happens basically? So the condition not satisfied, simply it is trying to return as a null. But current example, you can see, like whatever the key we provided 4, 5, 6. So we find out the node. Okay, this is the node we find out 4, 5, 6 and the value. Okay, 4, 5, 6 and value. This is what we need to understand here. So now here what I am doing, first dot hash and the second whatever the hash we generated, both the hash and the code are matching or not. So it is matching here. Okay, it is matching. Now it is returning the node object. When we are trying to return as a node object. So whenever we are trying to return as a node object, what happens basically? The object is available, so it is trying to return not equals to null, and here we are trying to get as a true value. So now you can see true we are getting, because the 456 and this particular 456 already existed into this particular Hashset. It's a simple understanding here. What we are doing basically, so contains method purpose basically, whenever we are providing the parameter value is existed into this particular Hashset or not, it is going to check here. If it is exist, it will try to return true. Otherwise, it will try to return as a false here. So this is what we need to understand here. But here, each and every class implementation is different. So that is we need to understand very carefully. So contains we observe. And here, iterator and the list iterator will discuss later. To array. So what exactly the to array is doing now? It's a simple understanding. So to array basically, what is doing now? What exactly the to array will do now? Here you can see to array, we are creating an object. Here we are trying to create an object. Okay, so whenever we are trying to create an object here, what we can understand basically, after the size, based on the size, we are creating an object array, and we are doing the iteration one by one. We are repeating, and we are adding here. Here we are adding. It's a simple understanding. So whatever the object we are having, the object we are converting into the object array. Okay, so now finally Hashset will convert it into the object array. So some cases, if you want to use the object array, then we can call the to array. It will convert object array. We can perform the other operations. Okay, so remove method. Remove method. So what exactly the remove method will do now? Hashset dot remove method. So what we need to understand here regarding this particular remove method. So I'm going to pass same 456. So first we'll go for the 458. So how it is going to be removed here? So we need to understand the two cases. One is a positive case and one is a negative case. Like this object, it is not available as of now. This object, it is not available. So we'll see if the object is not available, what is the operation it is going to do. Okay, remove method I'm calling. Now you can see, so map dot remove here equals to present. So it should satisfy with the present object here. What is the present? The present we are making as a value. Okay, the present we are making as a value. So now this is the remove method. What you need to understand here? What you need to understand here? So hash code we are having. First we are generating the hash code and we are calling the remove node. And we are calling this particular remove node. So let's generate the hash code. This is the hash code and I'm calling the remove method. So now observe carefully. So it's the same. If you remember, contains method logic and remove method condition is same. So you can see this is the condition we are using. This is the same condition we are using. So in our case, what happening basically here? This is will satisfy. Okay, the first condition will satisfy, but the second condition will not satisfy. Why it will not satisfy? because whatever the hash code and whatever the key we given, based on this particular key, we don't have object. We don't have object under this particular hash set here. So now you can see it is trying to return as a null. Getting the point. So this is we understand. So finally, what we understand here, first we are generating the hash code. Based on the hash code, we are trying to load the object. If the object available, it will load an object. Otherwise, simply it will try to return as a null here. This object, it is not going to be removed. Okay. So now I'm making 456. Now I'm making 456. So whenever I'm making the 456, now what happens? Object is available. We are generating the hash code. So based on the hash code, we'll load an object. Now after that, we'll try to remove the respective object here. Okay. So now you can see the object is available. We loaded the object. So what is the P? The P, we are trying to load the 456. So this particular 456 object, now it is going to be removed. So now you need to understand, just we are declaring this, like node we declare as a null, and we declare E, and we declare K, and we declare the value. Okay. So now come out of this. So P dot hash. So hash will be same, key will be the same. Okay. In our case, the node we are providing. Now, the P, whatever the P we loaded, so that is we are initialized into this particular node. Okay. So node not equals to null and matched value. So what is the value we provided? False. So it will become true. And here, this is the R condition. These are the R condition. So no need to check anything. So simply we can go to the next line. So instance tree node, it is not a tree node. Now node equals to P. So now you can see node not next. Node dot next. So what happening? The node does not contain the next record. Okay. The node does not contain the next record. Whenever it is not contain the next record, simply it will initialize as a null. So here you can see what is returning. Result null we are getting. So why we are getting? The current node, it does not contain the next node. Okay, it does not contain the next node here. Okay, so this is what we need to understand. So mark on, we are decreasing the size. After the node removal, we are not doing anything. So whatever the node we removed, the respective node, we are trying to return here. Okay, so it will match here. Simply, it will try to return as a true. So now you can see the size is decrease. Okay, so if you want to understand here, before the calling the remove method and after calling the remove method. So we'll understand the size. First 6 we are getting. After removing, we are getting as a 5. Right? So this is important. So simply understanding here, mainly for hash code, it is going to be plays a very important role in setting, updating, deletion. Getting the point? Or loading the node also. For loading the node also, what we are doing is first we'll generate the hash code. Based on the hash code, we'll find out the record. Then the record we are trying to return. Okay. So this is what we need to understand. Now we observe the remove. So what exactly the removal method will do? It's the same. So internally, it will try to call the Hashset dot removal. So let me keep this list. Okay. Removal. Now what you can understand here, you can see here, you can see this removal basically what we are doing. We are checking the object required not null. After that, we are checking the size greater than this particular size. So then it will call this. Otherwise, it will go to this. So any case, okay, if you understand any case, what we are doing is the remove method we are calling. Here also we are calling the remove method, and here also we are calling the remove method. So one by one, the record will remove. Okay, whatever the remove logic we just now we observe, the same remove logic is going to be executed, even though we are calling the remove all method. But only the difference is remove all internally work with the loop to pass the object as one by one. Okay, the remove method is expect only one parameter at a time. So in that case, what we are doing, we are passing the value one by one using the for loop. Okay, so this is what we need to understand here. So now it's a simple understanding. Remove method is expecting the one parameter, whereas the removal method, it will expect as a multiple parameter. So in that case, whenever we are expecting the multiple parameter, the multiple parameters are going to pass as a one by one using the for loop. Okay, so this is. Now what about this particular retain all? Retain all is a simple method. Whenever matched records are will keep, unmatched records are going to be removed. So what are the matched records? So the matched record basically has set dot retain all and list I'm passing. Okay, so I'm passing the list here. So now here what we need to understand here. Now what we need to understand here. So has set dot retain all. So what exactly the retain all method will do now? What exactly? Retain all. So here list we are having. So these are the object I passed. Okay. Whenever I'm passing these objects are going to match it, and these are objects are going to not match it. Getting the point? These objects are not going to be matched. Only these objects will keep, and these objects are going to be removed. These objects are going to be removed. So this is only the main differences between the retain all. Retain all is a simple method. Whatever the parameter we are passing, the collection parameters records are going to be compared. If any record is matched with the existing Hashset object, the record will keep as it is. Any record does not match with the existing Hashset, those records are going to be removed here. Okay, so now observe this. After calling the retain all, you'll get only 3 records. Only, okay, so here I'm removing the 4, 5, 6. Here I'm removing the 4, 5, 6. Because of that, I'm getting 2. But now, if I'm going to run the same example, you'll get 3 objects. You'll get the 3 objects. So size you can see 6 and 6 we are getting. But now, after calling the retain all, I'm able to see only 3 objects. So what happened this particular 3 records? What happened for this particular 3 records? Getting the point. So what you need to understand basically here, these records are matched with the existing Hashset, but these records are not matched. Because of that, it's removed. Okay. So we'll see the simple logic how this particular retain all is implemented. Any collection you can take, the purpose is same. The retain all method will do the same functionality, but each and every implementation class is having the implementation is different. Because array list is work with object array, whereas a linked list it work with a node, and Hashset internal is working with a hash map. So hash map internal is using the concept called node. Okay, but while inserting the record into the node, we are generating the hash code. Based on the hash code, we are trying to store into the respective index location. So this is what we need to understand here. Okay, now you can see retain all calling. So here modified I'm making as a false here. Okay, after that I'm calling the iterator. So now here you can see what I'm calling contains method. So contains method. So contains method basically if the record is available, so that will return true. Whenever the record is not available, okay, here you can see here we are using the not operator. Whenever the record is not available, simply we are calling the remove method. Simply we are calling the remove method. So this is what we need to understand here. This is what we need to understand. So contains method, when it is going to be written true or when it is going to be written false. The parameter, whatever the parameter we are passing, the parameter, if it is available, okay, the parameter value, it is available in the existing object, existing collection, simply it will try to return true. When the same collection, when the same parameter, it is not available in the collection, what happens? It will try to return as a false. So whenever it is trying to return as a false, what happens basically? So it is not going to be remove that particular object. But here we are using the not operator. So not operator, what exactly it will do? For example, contains method, it is trying to return as a true. Okay, the true will become false. Okay, the same contains method, same same contains method. So if it is returning false here, so that will become true. So that will become true. So whenever it is trying to return as a false, the respective object is become true and it is going to be removed. So what we can understand false means the object is not available under this particular collection. Under this particular collection. So this is what we need to understand here. Okay, so this is what we need to understand here. So now those objects are going to be removed from this particular respective collection. Okay, so retain all also it's a simple method. We can easily understand it's using the contains and it is trying to remove the object. So clear method. The clear method basically what it will do, it will remove all the objects. Okay, it will remove all the objects here. So how exactly it is going to be remove this particular object here? To understand this particular clear method, here map.clear we are calling, and here you can see, so we are using the if condition. Okay, we are using the if condition, so that if condition will satisfy. After that, we are using the for loop. After that, we are using the for loop. And here, each and every record, what we are doing is, we are trying to initializing as a null. Getting the point? Here, we are trying to initializing as a null. So here you can see node array. Node array. So array type, this is our array type we already discussed here. So whenever we are working with array type, we need to work with the indexes. Okay, we need to work with the indexes. So that is we are doing here. Okay, so here each and every object is now removing here. So we are making a null. Null means so all the objects are going to be removed here. How many objects we are having? 16 objects. Okay, 16 objects. So here all elements are null. All elements are null here. So now whenever I'm trying to print this, so empty object is printing. Empty object it is printing here. So why this empty object it is printing? Because here all the objects are removed here. Getting the point? All the objects are removed from this particular Hashset collection. Okay. So now if I'm going to call the size here, after the clear, if I'm going to call the size, now you'll get this 0. Now you are getting as a 0 because earlier 6 object we got it. All the six objects we removed. Okay. So this is what the clear method will do. So equivalent to hash code method. Equivalent to hash code method. So what exactly the equal and hash code method will do? So equal method I'm passing, and here I'm trying to pass with a 458 here. Okay, so what we can do, we need to run the equals method, how it is implemented internally, how it is implemented. Now you can see, so abstract set we are having, and we are trying to check the if O equals to this. So O basically we are passing as a string object, but this currently it is trying to work with the collection. So both are not satisfied. Simply come to the next line. If it is whatever this particular set we are having, okay, whatever the value we are providing, if it is not a set, okay, simply we are trying to return as a false. But in our case, we provided this object. This object basically it is a string object. But what is expecting? Oh, it's instance of set. Okay, it should be instance of set only. If other than this particular set, if you provide any object type here, simply it will try to return as a false here. Okay, so you can see it is trying to return as a false. So what you need to understand here, if I'm trying to provide a string here, if I'm trying to provide a string, so what we are getting? True. What you are getting? True. But what if I'm trying to providing set here? Okay, if I'm trying to providing set. So now you are getting as a false here. So finally, what you understand here, what you are expecting basically, we are expecting here, whatever the object we provided, the object, it should match with the set type. It is not, if it is not matching other than the set, simply it will try to return as a false. Okay. So if it is matching the set, we are doing this particular size. Otherwise, we are calling the contain all method. We are calling the contain all method. The contain all internally, it will call the contain method. So each and object it is going to be compared and it will return true. Okay. So this is we can understand here. So simple understanding. So equals method basically what we did, first we are checking the parameter object with the current object. If the both are matching, simply return true. Otherwise, what is the next step we are doing? So even though if it is not matching, we are checking with the data type. So the parameter data type. The parameter data type, it should match with the set here. If it is not matching, what we are going to do? Simply we are returning false. Okay. So in that case, if it is matching, simply we are calling the contains all. Contains all internally we'll call the contains. Contains, it's keep on checking the one by one object. So that is what we need to understand here regarding the equals method. So whatever the hash code, method. So now, if you understand the hash code, it's a simple understanding. Now here you can see object dot hash code. Object dot hash code. So in our case, this object dot hash code, which method it is going to be called? What is the generic type we are using? String. Here we are using the string generic type. So whenever we are using this particular string generic type, what happens basically? Here, we need to understand the string class internally, whatever the hash code is implemented, the respective hash code it is going to be called. The respective hash code it is going to be called again. So in this is very important, we need to understand it. Okay. So this is what we need to understand here. Now, okay. So after this, so these are the methods we discussed regarding this particular Hashset. So any method having any issue, or you need to clarify any method, so how it is going to work internally, or all are fine. So anyone having any questions? Okay. So simple understanding, Hashset, it is not going to allow duplicates, and Hashset internally it is using the hash map to insert the record. Hash map internally it is using the node. Okay. Internally it is using the node to insert the record. To insert the respective node index location, we are going to work with the hash code. So hash code and the length will generate the specified number of index location. Then the record it is going to be inserted into the respective node array. Okay. So this is the way the Hashset is implemented internally. This is very important because the entire collection framework it is going to be play as a very important role whenever we are trying to work with any real-time applications. Okay. So because of that, I'm trying to provide each and every method implementation, how it is implemented internally, so that we can easily understand it. Now, so this is the set interface we completed. So under the set, whatever the class we discuss here, this is the one of the Hashset implementation. But here, what about this particular sorted set? Okay, sorted set is the implementation of this particular which class. So now we need to understand this is also interface. Internally, it is extending from the set interface. Okay, so let's see this is the first implementation we identified. Now the second implementation we need to understand. So that is called linked Hashset. Okay. So what you understand here, let me provide the diagram. This is a collection. Okay. And this is a list we are having, and the list internally implemented by array list and linked list. So here we are having set here. So currently we discuss about the Hashset is the implementation, and the second implementation class linked Hashset. Linked Hashset here. So now we are going to discuss this particular class. So once it is completed, now we'll go to the queue related here. Okay. So now, so what we are doing here? Okay. So we need to understand the second implementation class of this particular linked Hashset here. So now we'll see how exactly the linked Hashset internally it is implemented. So linked Hashset basically internally it is extending from this particular Hashset. So to understand here, linked Hashset. Here I'm trying to work with the integer. The Hashset we discuss about the string related generic type. Now this particular class we are going to work with the integer. Okay. So now linked Hashset and linked Hashset. So currently first we need to understand the implementation for extend class. So linked Hashset internally it is extending Hashset. So just now we discussed Hashset. Okay. Now it is extending. So this is a subclass of this particular Hashset. Now it is implementing set interface. So these are the two other interfaces we'll discuss later on this. But now you can see, so if we understand the hierarchy, now the hierarchy, how it is looking. So this is the set interface, set internally extending from the collection. Okay. And here we implemented the one class called Hashset, and Hashset internally it is using the linked Hashset. So whatever the method we are having, so in most of the cases it may call to the Hashset or it may be implemented only. Okay, so we need to understand it. Now we'll see how this particular class is implemented, what is the purpose of this particular linked Hashset. So linked Hashset, as we discussed, it is extending from this particular Hashset, and so there is no specific method under this particular linked Hashset, and it is going to use the same generic type. So however we use the Hashset generic type here, so same way it is applicable to use the generic types here. Okay. Now here the linked Hashset internally it is going to use it is going to maintain the linked list. Okay, internally it is going to use the linked list of the entire set here. Like whatever the records we are going to provide, the records are going to work with the linked list here. So the linked list, we observe the node concept here. The node will contain the next node and previous node. So same way here also it is going to provide this particular information. Okay. And the second one, so whatever the order we inserted, like whatever the order we are trying to insert here, the same order it is going to be inserted here. Okay. And here the same order we are going to load the data. So Hashset it will not do the same, but linked Hashset it will do here. Getting the point? This is very important. So this is the main differences between Hashset and linked Hashset. Hashset and linked Hashset here. So linked Hashset basically it will do the linked list mechanism to store the values and to load the respective objects here. Okay. So now we'll see what are the constructors. What are the constructors we are having? So now you can see, so we don't have much methods here. As I suggested, it is not going to use any specific method. All the methods are copied from the Hashset only. But here you can see constructors. So this is the first constructor. So this is the first constructor which is expecting the two parameters. So initial capacity, load factor. Now we are calling the super. So super means which class constructor it is going to be called. So which class it is extending? Hashset. The Hashset constructor it is going to be called. Okay. And the second constructor, so simply we are calling the initial capacity. Simply we are calling the initial capacity. Even though we are calling the initial capacity, again it is calling the super constructor by passing the initial capacity, load factor, and dummy value. The load factor will play a very important role whenever the capacity it is going to be reached here. Okay, in the previous example we already discussed here the load capacity we calculated 12. So the capacity we are having 16. Whenever we reach to the up to 12 records, so it is going to create a bigger Hashset object so that we can copy the existing and we can insert the new values here. We can insert the new values here. Okay, so this is what we need to understand the constructors. The second constructor is completed, and default constructor. So default constructor we are passing initial capacity 16, load factor, and dummy value. And this is a one more constructor which is expecting the collection. Okay, which is expecting the collection. So we already identified this particular constructor in the Hashset, and after that it is calling the add all method. It is calling the add all method. Now this is a split iterator which is added from the 1.8 here. Okay, so we'll discuss later on this particular split iterator. So other than this particular constructor, nothing information is available under the linked Hashset. So what exactly the linked Hashset will do now? Okay, so hash table and linked list implementation of the set interface. So hash table, like hash table means the hash code related logic and linked list. So both the logics are implemented from this particular linked Hashset class here. Okay, so here which is predictable iteration order. Getting the point? So this implementation differs from the Hashset in that it maintains a doubly linked list running through the entire the linked list here. So basically, so it is going to use the same linked list mechanism it's providing. So just read this particular piece of line, so you will understand what exactly the linked Hashset will do here. What exactly the linked Hashset will do. So now we'll try to add a record. So we'll try to add a simple records here. Okay, so now linked Hashset dot add, because we don't need to discuss any method, because linked Hashset does not contain any specific method except the constructors. Okay, any method we are calling, so that will call the Hashset. That will call the Hashset here. So what I'm doing here, now I'm passing 1, 2, 3. Okay, sorry. Here I provide an integer. Okay, so around 6 or 7 object. So this is I'm giving 789 and 963 and 741, 852 and 456. So these are the objectives. After that, now what I'm doing, so simply I'm going to print this linked Hashset. Simply I'm going to print this particular linked Hashset here. So now you can see whatever the order we inserted, linked Hashset 1, 2, 3, 789, 963, 741, 852 and 456. Getting the point? Whatever the order we inserted, in the same order we are getting. But if you understand here whether it is calling the, like it is generating the hash code or not. So now you can see this. I'm calling the add method so that we'll understand the internal implementation. Okay. Now here you can see which method we are calling, add method and map.put method. Okay, map.put method. So the map.put method and internally it is calling the hash map. So hash map, first will generate the hash code. First we are going to generate the hash code. After that we'll call the put value. So now hash code you can see the 1, 2, 3 and key also we are having 1, 2, 3. Key also we are having 1, 2, 3. So this is the table. As of now the table is null here. As of now the table is null because first record we are inserting. So go to this particular resize method. So this is the resize method based on the new threshold, the new capacity we are going to construct. After that, what we are doing here, we are trying to create a node array. So line number 699, we are trying to create a new node array. Okay. So now go to the one by one. Now here you can see, so node, the node capacity we created here, all elements are null. But what is the capacity? 16. So the node array we created, and after that we are trying to inserting the value. So now where we are inserting? Here. So table, this is the particular object here, and n we are having length 16 object we can store. So currently, so table n minus 1 hash, what we are doing is any object is available, or this is the first record we are checking here. So this is the first record. So what is a p object is null? What is the I value? I value we got as 11. I value we got as 11. So when we are trying to store the value in the 11 index location, so not in the 0. But even though we are trying to store in the 7 index location, okay, we are trying to store in the 7 index location, what happens here? But whatever the order we inserted, in the same order only we are getting, because of the linked list mechanism. So internally, it is implemented the linked list mechanism, even though it is trying to generate the hash code and the equals related operation, but still whatever the order we inserted, in the same order we are getting it. So to understand one more example, I will work with a string here, so that we may understand here. Okay, so now go to this. Where is the hash set? Here is a hash set here, right? Okay, so ABC, XYZ, and DEF. So if you remember, we got ABC, after the DEF, after that XYZ, whenever I work with the hash set. But now you can see the linked hash set. Now you can see the linked hash set, how it is printing these values. Okay, ABC, XYZ, DEF. Getting the point. So this is a different implementation of the set interface. Getting the point. This is important here. Okay, so is it clear? The hash set will do the, based on the hash code, it will go for the specified index location, and it will load the based on the hash code. Okay, the hash code initially how it is going to follow. So let's say hash code for one object we got 10, and hash code we got second object 20, and hash code we got third object 100. So fourth object 50. Okay, sixth object something like 80. So what exactly it will do? How the objects are going to be ordered here? So 10, 20 in the third index location. So it will go to the 50, and fourth index location 80, and last index location 100. So these values are going to be replaced with this is the sequence here. Okay, because of this, now we are not getting the insertion order as a same whatever we are going to insert it. But using the linked hash set here, the linked hash set internally it is using the linked list mechanism. So even though we are trying to work with the hashing mechanism, but still it is going to follow the insertion order as the same whatever the order we are going to insert here. Okay, so is it clear? So still any questions? Okay, so now whenever we don't have anything, now so you can work on the all the implementations, like we observe the add method, add all method. So whatever the method we are having, all the method you can work with this particular linked hash set here. Now, so we need to understand the another important implementation class of the particular set related interface. So set related interface means by default internally it is implementing from the navigable set here. Now let's observe the one more class. So that is called tree set demo. Okay, so tree set demo. So this is the tree set. Here I'm going to use the integer. Okay. Now here default constructor. But finally, what we need to understand here, we need to understand the tree set. So tree set internally, it is extending from the abstract set. Okay. So same way, hash set also internally it is extending from the abstract set. Why the linked hash set it is not extended? Because linked hash set internally it is extending from the hash set. So hash set internally it is extending from the uh, abstract set. So if you observe, so this is the first class called abstract collection, and abstract collection internally it is extended by the abstract set here. So abstract set internally it is extended from this particular hash set. Okay. And hash set internally it is extended by this particular linked hash set. Now for one more branch here, so this particular class is extended from this particular tree set here. Okay, so hash set is as of now it is extended from this particular tree set as well as this particular hash set here. So hash set internally it is extending from this particular abstract collection, and abstract collection it is implemented. Okay, it is implemented from the collection interface. So this is the hierarchy we need to understand. Okay, now we observe. But here you can see navigable set. Okay, here we are having navigable set here. So if you remember, hash set internally it is implemented from the set interface. But whereas this particular tree set, it is not implementing the set. It is directly implementing from the navigable set here. So navigable set internally, it is extending from this particular sorted set. Okay, so sorted set internally, it is extending from the set interface. So now you can see, so directly the top level interface we implemented, but the tree set, the child, okay, the sub interface we implemented here. Because the navigable set internally extending sorted set internally extending set interface. So finally, so set related method, sorted set related method, navigable related method, everything we can access from this particular class called tree set. Okay, so now we need to understand the what is the purpose of this particular tree set. Getting the point? So as of now, so hash set purpose. Okay, so what exactly hash set will do? So hash set, so insertion order it is not going to follow, and the duplicate objects it is not going to be inserted, and internally it is using the hash map, and hash map will do the node concept to insert the record. Whenever we are trying to insert the record, we are following the hash code mechanism. Okay, so this is the purpose. So whereas a linked hash set basically, so even though it is using the hash code mechanism to insert the record, but it is following the insertion order preserve. Like whatever the insertion or whatever the order we are going to insert, the same order we are going to get the value because of linked list mechanism. Okay, so this is the linked hash set. Now we need to follow the tree set. Okay, the tree set. So the tree set basically, as we understand, it is extending and it is implementing from the navigable set here. So it is going to create a collection to storage, like it is going to create a collection to purpose of the store as the entire collection. But mainly the objects are going to store as a ascending order. Getting the point? Ascending or descending order. So we can work with this particular tree set. Okay, so finally we understand here each and every class we are having the purpose here. So whatever the important we need to basically whatever the requirement we are going to get here. So based on the requirement which class is suitable, then we'll work with the respective class here. So hash set, linked hash set, or else we will go for this particular tree set here. Okay, so main purpose of this particular tree set, it will provide the object in the ascending order. If you want to provide the descending, so we need to implement some other logic, so that will explain later. So we'll see how exactly it is going to be implemented as ascending. So whenever it is implemented as ascending, so the access of retrieval time, it's very fast. Getting the point? So access of the retrieval of this particular each and every object, it's a little faster. So because of that, we can go for this particular tree set here. Okay. Now we'll see the uh, constructors. What are the constructors we are having here? The constructors here you can see. Now if you understand here, the tree set, okay, tree set internally, what is an object it is using to store the values? Navigable map. Okay, navigable map here. Okay, but hash set internet is using the hash map. Internet is using hash map. The tree set internet is using the navigable map. Now this is the default. Sorry, this particular constructor is having default access modifier. This constructor we cannot call. This constructor we cannot call. So which constructor we can call here? So we can call this particular constructor that is called tree map. Okay, tree map we are going to call here. So once we are calling this particular tree map, now here you can see what I'm doing is, so this is the constructor I'm calling by passing this particular tree map. So tree map internally it is extending navigable map. So this dot m is equals to m. Okay, finally the navigable map object we are going to create. So second one, if you remember, this is the tree set. Okay, this is the tree set constructor which is expecting the comparator. So as of now, we did not discuss about this particular comparator. Okay, we'll discuss later once we are having basic example. Later we'll discuss comparator, what exactly it will do. So now this is the collection related constructor. Okay, and so this is the sorted set. Here we can pass the interface related. So it will call the this that comparator and it will call the add all. Now, so these are the iterators. But you can see, but what you understanding, how many constructors we are having. The first constructor, this constructor we cannot call. Okay, so first constructor is this because we are having a public. So the public related constructors only we are going to call here. Now here, what we need to understand basically here, this dot tree map we are calling. Second constructor expecting the comparator, third constructor expecting the collection. So these are the fourth constructor also we are having, it is expecting the sorted set. Okay, so if you observe, this is, we can pass array list, linked list, we can pass some other collections, but here this particular parameter we cannot pass. This particular parameter we cannot pass here, the array list and linked list. So we can pass only the tree set here. Getting the point? So this is what we need to understand. These are the four constructors we are having. Now, so observe the add method. Add method. Now you can see add method m dot put. What is m? M is a reference variable of the particular navigable map. M dot put we are calling. So same remove m dot remove. Okay. So finally, the tree set internally it is working with the navigable map. Okay, so whenever it is working with the navigable map, we need to understand how the records are going to be inserted as ascending order. So when we are trying to work with this particular comparator, we can work with different ways, like a descending order. I want to sort based on the name. I want to sort based on the age. I want to sort with based on the ID. So that kind of behavior we can achieve with the help of this particular comparator. So we'll see how we can use this particular comparator. Okay. So I'm stopping the session up to here, up to the constructor. So in the tomorrow session we'll discuss about the each and every add method, the remove method, contains method, okay, retain all method, how it is implemented. So how the tree set is working as a like converting object as ascending or descending order. So that we are going to discuss in the tomorrow session. So once this particular tree set is completed, the set related implementations classes we are going to complete, and later we'll discuss about the queue related. Okay, the queue related implementation classes here. So any questions? Still anyone having any questions or regarding our today's session? Okay, so we'll continue tomorrow.